All right, welcome to our next lesson of Module 7. Today we are going to be working just a little bit more with square roots and radicals. So by the end of this lesson today, you'll be able to estimate the decimal equivalent of non-perfect square roots and then compare them to other numbers. So we're just going to be kind of like ordering numbers today that don't look like normal numbers we're used to. You'll know you're successful when you can estimate the equivalent decimal of a non-perfect square or square root, and then order them from least to greatest and determine which whole numbers they lie between. Okay? Keep in mind that this is going to be in your test later this week on Friday. So in the short term, it is very important to your life. In the long term, this is stuff you're going to use all throughout high school and college. So it is very important for you. Pay attention today, get everything done, and we're going to go ahead and get started. All right, we're going to start off with just a little bit of background knowledge and skills. So I have 3 equations for us to solve, and I'm going to start off just practicing them with you. So this first one is the cubed root of 27. So we should start having these numbers memorized by now, but if not, you know that something times itself 3 times equals 27. You could start with 2 and work your way up. 2 times 2 is 4, times another 2 is 8, so it's not going to be 2. Move to 3. 3 times 3 is 9, times another 3 is 27. So this number actually equals 3. The cubed root of 27 is 3. The next one we're going to do here is the square root of 16. So what times what equals 16? You could start off however you want to, but you should have this one definitely memorized by now. The square root of 16 is 4. 4 times 4 equals 16. So my equation becomes 3 plus 4, and 3 plus 4 is 7. Okay? Moving down below, we have a couple more of these. We have the cubed root of 64. So before we started off with a 3. So I'm going to move up and I'm going to try 4. What is 4 times 4? 16 times another 4, 64. So this actually equals 4. The cubed root of 64 is 4. And then moving on to the second one, the square root of 25. You should have this one memorized. What times what equals 25? Well, 5 times 5 equals 25. So this becomes 5. So 4 plus 5 is 9. Forgot to do that arrow up there. All right, and then moving down to the one below, we have the cubed root of 125. So this one is a little bit bigger. Something times itself 3 times equals 125. So we already did 4 right above, and that equals 64. So let's start with 5. Well, 5 times 5 is 25. Times another 5, you got it. It was 125. So the cubed root of 125 is 5. And now we're going to find the square root times 2. So 2 root 25. So we have a couple of steps here, and I'm going to put them down below. So the 2 times the square root of 25. The square root of 25 is 5, right? So this becomes 2 times 5, because we kept our 2 that was on the outside. That's not our index. That's actually a number being multiplied by the root of 25. And so the first thing I'm going to do here is solve my parentheses. 2 times 5 is 10, so this becomes 5 plus 10. 5 plus 10 equals 15. So this is just some review of some background knowledge that we've learned so far. And we're going to move into some new learning today and some more practice with things we've already known. All right, let's move forward. All right, we're going to jump right into this learning today. It says, without using a calculator, because we're not allowed to use a calculator for these standards, choose the statement that best describes the value of the square root of 86. So the first one says the square root of 86 is between 9 and 9.5. The second one says it's between 9.5 and 10. This next one between 10 and 10.5. And the last one between 10.5 and 11. So we are going to estimate where this square root of 86 lies based on what we know about these other squares. So I'm going to draw a number line out, and I'm starting with the number 9 and I'm going all the way up to 11. So I have 9, 10 in the middle, and then I have an 11. And the other numbers they give me are 9.5 and 10.5. And what I'm going to do with these is I'm going to figure out what is the perfect squares that these represent. So starting with 9, 9 is the same thing as the square root of 81. Okay, you should know that by now. We know that perfect square. 10 is the same as the square root of 100. Those equal the same thing. And 11 is the square root of 121. All right? The numbers I don't know the square roots of, or the squares of, by heart because they're decimals, are 9.5 and 10.5. So I'm actually going to solve those off to the side. So I have 9.5 squared is the same as saying 9.5 times 9.5. Remember, I can't use a calculator, so I'm doing this by hand. Okay? 5 times 5 is 25, carry the 2. 5 times 9 is 45 plus 2, 46, 47. I put a space holder because I'm done with that 5. 9 times 5 again, 45. Keep my 5, carry my 4. 9 times 9, 81 plus 4, 82, 83, 84, 85. From there, I add these numbers up. And then I look at where my decimal was. I had 1, 2 spaces for my decimal, so I'm at 1, 2. So 9.5 is the same as the square root of 86.25. It's not a perfect square, but that's the square root of. Okay? Now I'm going to do the same thing for 10.5. I want to find what is 10.5 squared. So 10.5 times 10.5. Well, 5 times 5 is 25. Carry my 2. 5 times nothing is nothing plus 2. 2 and 5 times 1 is 5. Done with that 5. Cross it off. Placeholder. 0 times everything is 0. Done with that 0. 2 placeholders now. 1 times 5 is 5. 1 times 0 is 0. 1 times 1 is 1. Add it all up. And find my decimal placement. 2 spaces in. And so the square root of 10.5 is 110. Or sorry, the perfect square that relates to 10.5 is 110.25. All right, now I have these all drawn out. I'm going to go back to my original question. It said, where does this square root of 86 fall? So 86, square root of 86, it's going to be higher than this 9. Right? It's going to be bigger than the square root of 81, but it's going to be less than this 86.25. So it's going to be in between these 2 spaces. This is where my square root of 86 falls. So in between 9 and 9.5. That was my answer here. So my answer is A. Okay, make sure you have this down. We're going to move forward to our next example. All right, my next example says, without using a calculator, order the following numbers from least to greatest. So what's nice is that I have 2 whole numbers, 5 and 4. Okay, so I can go ahead and place those on a number line. Let's just start with maybe 3, 4, 5, 6. So I know that I can put 5 right here. And I can put 4 right here on the 4. Now I need to figure out what's the square root of 14. So what times what equals 14? Well, I don't know. And I don't know how to find this without a calculator. So what I'm going to do is I'm going to figure out what square roots come right before it and right after it. So there's a perfect square that I know that comes right after it, which is 16, right? And the perfect square that comes before it is, well, 16 is 4 squared, so 3 squared, 9. So these are the perfect squares that come before it. Remember that 9, the square root of 9 is 3, and the square root of 16 is 4. Now this is a little bit less than 4. So it's going to be in between these 2 numbers right here, in between 3 and 4. So this blue dot is going to go in between 3 and 4. I'm just going to put it right there. Okay, now I have them ordered from least to greatest. So my blue dot, this is the first that I find. This is the least. So I have the square root of 14 first. Next comes my green dot, 4. And next comes my red dot, which represents my 5. So this is my ordered least to greatest numbers. Okay? Down below, it says without using a calculator, fill in the blanks with two consecutive integers. This means numbers that are back to back. Okay, to complete the following inequality. So what I'm looking for is I'm looking for two numbers that come directly before and directly after the square root of 111. Well, I don't know what the square root of 111 equals, but I know that there's a perfect square that comes after it and before it. So I'm going to look for those. So what perfect square comes after 111? So I'm thinking of my list, 111, well 10 times 10 is 100. 11 times 11 is 121, so 121 is right after it. And I already said the one before it, 110 is right before it, or 100 is right before it, sorry. And what I'm going to do is I'm going to figure out what does this number actually equal. What is the square root of 100? The square root of 100 is 10. And what does this other one actually equal? What is the square root of 121? Well, the square root of 121 is 11. So the two consecutive integers, back-to-back numbers that this falls in between, it's right in between 10 and 11. Okay, make sure you have this down, and we're going to move forward to example number 3. All right, for example number 3, it says without using a calculator, match each expression to a correct point. Please disregard this up here. That's from an old lesson. Don't look at that. All right, so the first one we have is 3 pi. So one thing you should know about pi is that it's an irrational number, and we're going to learn about that tomorrow, but the decimal that it represents is 3.14. So this is the same as saying 3 times 3.14. That's what we round it off to. In all actuality, pi continues on forever, but that wouldn't make sense for us to do here, so we're just going to multiply it together, okay? The next one, the square root of 100. Well, you should know that the square root of 100 is 10. That one was pretty simple. And the last one, we're trying to find the square root of 78. Well, this is not a perfect square. 78 is not a perfect square. But there's some that come right before it and right after it, so I can say what it's in between. So right before this number, square root of 78 is the square root of 64. And right after this number is the square root of 81. So the square root of 64 is 8. Square root of 81 is 9. So it's in between 8 and 9. Okay, and that's where the square root of 78 is. Now the only thing I still have left to do is this math right here, 3 times 3.14, and I have to do it out by hand. So I'm going to do 3.14 times 3. 3 times 4 is 12, carry my 1. 3 times 3 is 3, plus 1 is 4. 3 times 3 is 9. Done with that. And I have 2 spaces for my decimal. So this equals 9.42. So I'm going to figure out where these points connect with. So this first one, I'm going to highlight in green, 9.42. Where would that lie? Well, it's going to be after this 9, before this 10. So it's going to be this y right here. So the point that this represents is y. Okay. The next one, I'll highlight in red. 10 was my answer. So it's literally just going to be this point that's right at 10. So what point represents that? Point Z. And the last one, obviously I only have 1 point left, but it's in between 8 and 9. Is this answer in between 8 and 9? Yes. So this point is point X. Okay, please write it down, and we're going to go ahead and move into our next part of this lesson where you get to practice these things a little bit. Okay, let me know if you have any questions before we move forward. All right, to go over our new learning for today, we can estimate the decimal equivalent of non-perfect squares by comparing them to perfect squares that we do know. So for example, we have the square root of 14. We don't know what that is, but we know that there's one that comes before it and one that comes after it that are perfect squares that we do know. So the one that comes after it is square root of 16, which equals 4. And the one that comes before it is the square root of 9, which equals 3. So we know that the square root of 14 is between 3 and 4, somewhere in between those two numbers. And then we can kind of order it if we have other numbers. The next thing you're learning today is that pi equals 3.14. The decimal is not actually going to stop at 3.14. It goes on forever, but when we're doing our math out with pi, and we're trying to approximate locations of numbers on number lines, we use just 3.14. You write that as a fraction as 22 over 7, but we're not really going to use that 22 over 7 right now, okay? In the last part of this lesson today, it says we know how to square a number. We know that to square a number is to multiply it by itself. So 3.5 squared is the same as 3.5 times 3.5. If I did that math out by hand, I would get 12.25, and that shows me the square root of 12.25 is 3.5, okay? Let's move into some practice today now that we've gone over our new learning. All right, what I want you to do here is find the square root of 74. What is it closest to? And it gives you a bunch of numbers. I want you to create a number line just like we did on that first example. Go back and look at example 1 if you're having trouble. But this starts at the number 8, and it goes to the number 10. And I want you to find what do these numbers represent when it comes to square roots. And then you'll find your answer. Where does the square root of 74 lie in between, okay? We're going to check our work in about 2 minutes. All right, so the ones that you should know that 8 is the same as the square root of 64, 9 is the same as the square root of 81, and 10 is the same as the square root of 100. What you don't know are these two decimals. So we're going to actually figure them out. So we're going to do 8.5 times 8.5. And I'm going to do 9.5 times 9.5 to figure out what these equal on our number lines. Okay? I'm going to go through this pretty quickly, so just bear with me. 5 times 5 is 25, carry the 2. 5 times 8 is 40, plus 2 is 42. Space holder for our 5. 8 times 5 is 40, carry the 4. 8 times 8 is 64, plus 4, 68. 5 plus nothing is 5, 2 plus nothing is 2, 8 plus 4 is 12, 6 plus 1 is 7, and our decimal is 2 spaces in. So this is the same as saying the square root of 72.25. All right, moving on to 9.5 times 9.5, or 9.5 squared. 5 times 5 is 25, 5 times 9 is 45, plus 2, 47. Done with our 5. 9 times 5 is 45, carry the 4. 9 times 9 is 81, plus 4, 82, 83, 84, 85. Add these up. 5 plus nothing is 5, 7 plus 5 is 12, carry the 1. 4 plus 1 plus 5 is 10, and 8 plus 1 is 9. We're 2 spaces in for our decimal. So 9.5 is the same as the square root of 90.25. Okay, now that we have these answers written down, we are looking for the square root of 74. So 74, we're above 64. We're above 72, but we are below 81. So square root of 74 is going to fall in between 8.5 and 9. It's going to be in between these two squares, these two numbers. Okay, so the answer here, 8.5 and 9, is B. Check your work with my work. Let me know if you're having any questions, and we'll talk about it before we move forward to the next practice page. All right, for this practice page, you are putting these numbers in order from least to greatest. Remember that pi is the same as 3.14. And that's going to help you out here. Take your time, do the first one, and then we'll go over it, and then we'll do the second one. Okay? All right, this first one I'm going to solve. I'll highlight it in blue so that you can see. I'm going to do pi squared. So pi squared is the same as saying 3.14 times 3.14. I'm going to do this math out. 4 times 4 is 16. 4 times 1 is 4, plus 1 is 5. 4 times 3 is 12. I'm done with this 4, done with that 1. Space holder. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. Done with that 1. 2 space holders. 3 times 4 is 12. Carry the 1. 3 times 1 is 3, plus 1 is 4. And 3 times 3 is 9. And I'm done with all that multiplication. I'm going to add it up. 6 plus nothing is 6, 5 plus 4 is 9, 2 plus 2 is 4, plus 1 is 5, 4 plus 3 is 7, plus 1 is 8, and we keep our 9, and we are 1, 2, 3, 4 spaces in for our decimal. So this number actually represents 9.8596. Okay? The next one, it's just a whole number, it's just 9, so I don't have to do any math there. And the last one, I'll highlight it in red, is 3 times pi. So I'm going to be doing 3.14 times 3. 3 times 4 is 12. 3 times 1 is 3, plus 1 is 4. 3 times 3 is 9. And I'm moving 2 decimal spaces in, so this is 9.42. So now that I have all these numbers out, I'm going to list them from least to greatest. So the smallest one of these is my green one, 9. Next, I have my red one, 9.4, 9.42. But remember, that was represented as 3 pi. So I'm going to use the exact terms they gave me to start off with. That means that my last one is the one in blue, 9.8596, which is the same as saying pi squared. So this is my order from least to greatest. That is my answer. Okay? Down below, I want you to go ahead and try the next part. Take some time, simplify these answers, and then order them from least to greatest. All right, this first one, the square root of 20. Well, I don't know what the square root of 20 is, but I know what it falls in between. So there's 2 perfect squares that come before it and after it. So the one that comes before it, square root of 20, is the square root of 16, which is 4. The one that comes after it is the square root of 25, which is 5. So I know that this first answer is in between 4 to 5. Okay, the next one, I'm going to be doing pretty much the same thing. I have the square root of 17. Well, I don't know what that equals, but I know 2 square roots that come before and after it. So again, before I have the square root of 16, which is 4, and I have the next one that comes after the square root of 25, which is 5. So that didn't really help me out much. I know that it's just in between 4 and 5 again. And then this last one here, 11 over 3. This is the same as saying 11 divided by 3. So I'm going to do this math out and turn it into a decimal. 3 goes into 11 3 times, which is 9. And I get 2 left over. I bring my decimal point down. 3 goes into 26 times, which is 18. And then I get 2 left over. Bring my 0 down, and it's going to be repeating. So this answer is 3.6 repeating. Okay? So I'm looking at these, and I'm going to order them. Well, I know that the blue and the green, those are both numbers that are in between 4 and 5. The red is 3.6. So the smallest number here is 11 over 3, the 3.6. Next, I have the square root of 20 and the square root of 17. Now, I know these both mean a number in between 4 and 5, but I don't know exactly what they equal. However, I do know that 17 is less than 20, so the square root of 17 is going to be less than the square root of 20. All right, so that is what comes next, the square root of 17. And lastly, we have our square root of 20. So we have ordered these from least to greatest by showing some computation out. All right, make sure you have this down. Let me know if you have any questions before we move forward. All right, for exercise number 2, I want you to tell me 2 perfect squares that this lies in between and what these whole numbers equal. Okay, so we have the square root of 32. So give me a square root that comes after it, a square root that comes before it, and tell me what those square roots actually equal. So what whole numbers does it fall in between? Okay, take a second to do this, and then we will check it. All right, so the square root that comes directly before 32 is 25, this perfect square. And the square root of 25 is 5. So the whole number it's in between is 5. And the next one, the one that comes after the square root of 32, the perfect square, is square root of 36, which is 6. So this number is in between 5 and 6. So they're the consecutive integers that the square root of 32 falls in between. Check your work with mine, and we will move on to the next slide. All right, for here, I want you to simplify what do these numbers actually equal, and tell me which points do they match on your number line above. So you have square root of 100, 3 pi, and then the square root of 104. So where do they lie on your number line above? Okay, take some time to show some work, and then we will go over the answers shortly. All right, this first one, the square root of 100, this is the easiest one here because the square root of 100, you should know, equals 10. And there's a point directly over the 10 right here. So this point is our y point. Okay? The next two, we have 3 pi and the square root of 104. So I'm going to work with 3 pi first. So 3 pi is the same as saying 3 times 3.14. And we've done this math out quite a few times already today, but I'm going to do it out again just for the sake of getting it done on the screen. 3 times 4 is 12. Carry the 1. 3 times 1 is 3 plus 1 is 4, and 3 times 3 is 9. We are 2 decimal spaces in. So this is the same as saying 9.42. All right, and 9.42 on our number line, it has to be in between 9 and 10. The only number that's in between 9 and 10 is this x, or the only point, I'm sorry, is this x point. So this represents x. That tells us that there's only one left, and that is 104. And that's going to be our z point here. And that should make sense to you because 104 is more than 100. So this is supposed to be more than the square root of 100, and that's where that falls. Okay? Check your work with mine. Let me know if you have any questions before moving on. All right, our lesson closure for today is that we can estimate the decimal equivalent of non-perfect squares by comparing them to perfect squares we do know. So, for example, if I were to estimate these 3 different numbers right here, I would compare them to numbers that I do know. So the cubed root of 27, I know that one. That's 3. Pi is 3.14, but the square root of 8 is something I don't know. I know what comes before it and what comes after it, so I can figure it out based on that, figure out its placement. So right before the square root of 8, we have the square root of 4, which is 2. And right after the square root of 8, we have the square root of 9, which is 3. So we know that this number is in between 2 to 3. Okay, it's somewhere in between those two numbers. And so if we were to order these from least to greatest, we would be able to do that saying, okay, well this one comes first, because that's in between 2 and 3. This one comes second, because this one is the number 3. And this one comes third, because this one is a little bit more than 3, okay? So we're going to use that knowledge today to help us out. Remember, if you're not ready for the exit ticket, go back through and rewatch some of these examples and exercises before so that you feel a little bit more confident. We're going to go over the exit ticket now. All right, your exit ticket for today is these 2 questions. So here's the first one, and here's the second one. You are not to use a calculator on here, so you have to show your work. If you're not showing your work, you're not going to get full credit because then I just have to assume that you use a calculator. So you're going to order these following numbers from least to greatest for number 1, and for number 2, you're going to place them on the number line. Okay? Keep in mind for number 2, these are negatives, so really don't ignore that fact because that does influence your number line. Okay? When you're done with this, please do your lesson reflection in Google Classroom, and we're done. Good job.